OK, before I can tell you about cookie policy, I have to tell you a little bit about domains and why they have these dots in between the words. So the dots create a hierarchy, and the hierarchy is kind of what you'd expect. We'll see this again when we talk about networking, but for now, just think of the dots as creating a hierarchy like you would expect. So for example, berkeley.edu and mit.edu, it makes sense that they both fall under this .edu domain. And cs161.org and edstem.org, it makes sense that they both fall under this .org domain. And if I had tune.cs161.org and sp25.cs161.org, it makes sense that they both fall under cs161.org. So it's kind of hard to put into words, but you can think of this tree. Hierarchies are basically what you expect. So, and here's another example. So we start at the top, and then berkeley.edu is underneath .edu, and ecs.berkeley.edu is below berkeley.edu. So works like you'd expect. So the reason I'm telling you about the domain hierarchy is because it's something we use to decide whether or not to set and send cookies. Now, this isn't the most glamorous slide. It's not the most exciting topic. But these are the rules that your browser uses. So let's go through them. So remember, the question we're trying to answer, this is kind of interesting, is if a server sends you a cookie, do you accept it? Or do you say this cookie has no relation to the server and reject it? Like the case where evil.com sent you a Google cookie, there's no relation. Now, the way that you check it, and it's a little bit boring, is you take the domain of the server, and here it's blue. So that is the server sending you the HTTP response. For example, if I contact evil.com and evil.com sends me an answer, then this value in blue would be evil.com. And the second value we have to compare is the domain of the cookie itself. Remember how cookies have all those different parts, and one of the parts is a cookie domain? This value in red is the cookie domain attribute. It's the thing inside the cookie. There are two different values. So for example, if you think back to our attack from before, where evil.com sent a cookie that was relevant for google.com, then this value in blue is evil.com because it's sending us the cookie. And this value in red is google.com because it's sending us a cookie to make Google dark mode. So in that particular attack, that's how you set these two values. Now, technically, the most formal way to write this rule is to say the domain attribute is a domain suffix of the server's domain. But I have no idea what that means, so I think of it like this. You write out x, you write out y, and you check if one of these is true. They all mean the same thing, so you choose the one that you like. You can either say x ends in y, you can say x is lower on the hierarchy than y, or you can say that x is more specific than y. All of these mean exactly the same thing. So here are some examples. Let's say that mail.google.com sends you a cookie. So you've contacted mail.google.com. They send you a cookie. If the cookie has domain mail.google.com, it's good. The thing in blue ends in the thing in red. Good. You can also say that this is below or equal to this on the hierarchy. That's also true. You can say this is more specific or equal to this. All of those are true statements. Now, mail.google.com can also send you a cookie with domain google.com. So think of this like Gmail sending you a cookie that's relevant for all Google services. That is also legal. Gmail can send you a cookie, and that cookie can apply to all Google services. And again, it's because this value in blue ends in this string in red. See how this string in red shows up here? Value in blue ends in the thing in red. You could also say this is below this on the hierarchy. You could say this is more specific than this. They all mean the same thing. So those are the two valid domains that mail.google.com can set in their new cookie that they're creating. And another example would be that google.com can set cookies if the domain is google.com. So that's all good. That works kind of like you'd expect. For example, Gmail can set a cookie that applies to all Google websites. That's good behavior that we want. But there's one little exception that we have to deal with. And the exception is that if google.com is able to set a cookie for domain com, and so far the rules say this is allowed, google.com ends in com. This is a little bit too general, because think about all of the websites that end in com. Google.com, Amazon.com, eBay.com. Do people still use eBay? I don't know, but that was the one I could think of. Okay, Google.com, Amazon.com, Facebook.com, all these different websites, they all end in .com. So if we allow Google.com to set a cookie for the entire com space, you're basically letting Google affect all of these other seemingly unrelated companies, like Amazon and Facebook. And even worse, if an attacker owns evil.com, you would be allowing the attacker to set a cookie for com. And now that com cookie affects Google, it affects Amazon, it affects Facebook, it affects eBay. That's way too many websites for this cookie to affect. So we're actually going to forbid cookies from having just this so-called top-level domain in their domain. It's just too broad. There's no way that a com cookie makes sense because it would apply to every single .com website, and that's just too broad. So it does make sense for Gmail to set cookies for all of Google. That's OK. But it doesn't make sense for Google to set domains for a cookie that is sent to all com websites. It's too broad. So we added this little hack, rule number 2, that says if this is a top-level domain, we just reject it. It's too broad. And again, the top-level domain is one that's right under the very top of this hierarchy. So .com, .edu, .org, all of those are top-level domains. They're not allowed. So those are the policies. You can set a cookie if the domain is more general than you, but don't set it for this top level. That's too general. So that's the rule. Now again, it's not super exciting, but that's how you check if a cookie can be accepted. So all of this is for someone offering you a cookie and you checking if the cookie is accepted.